Okay, another question was about a length of wire that's cut into two pieces. One piece bent around into a circle, the other piece into a square. And we want to find out at what point we need to cut the wire to minimize the total area of the two pieces. Okay, so that's what we're saying here. We want to get the minimum total area. We're going to cut this into pieces. So we say, okay, where are we going to cut it? We don't cut it anywhere, so we think of cutting it here or here or here or here. The point where we cut it is going to be variable, and we're going to mess around until we get a cut that gives us the minimum area. Of course, we want to do that mathematically, so we don't have to cut up a bunch of pieces of wire and do it experimentally. So our variable point at which we're going to cut it is going to be at point X from one end or the other, and arbitrarily we chose from the left end. So X is the distance from the left end. And we're going to form that piece into a circle and the other piece into a square. So we've got a piece of length X that we're going to bend around into a circle. I don't know how well I matched the dimension of the circle with X, but that's as it should be, and as it may be. Okay, circumference of the circle then is X. Okay, people identified that when we asked. Then I asked, okay, how long's the other piece? I don't think I got as many responses on that, but if you think about it, if this piece has length X and the whole thing is length 36, then this piece has to be 36 minus X. Okay, so you got a piece of length 36 minus X here, you're going to put that into a square. And I asked, what dimension of the square corresponds to that? I asked, what dimension of the circle, what dimension of the square? Got pretty quick answers, circumference up here. It took a while to get this answer, but people had came up with perimeter. So the perimeter of the square is 36 minus X. The perimeter of the square formed by this piece of length 36 minus X has got to be the length of that piece, 36 minus X. Okay, now we've got to get our areas, and this gets a little bit tricky. So I break it down, okay, and this is what you want to do when you solve a problem like this. You break it down one piece at a time. So, first piece, cut it into pieces. How are you going to designate the lengths of the pieces? Well, X, 36 minus X is good. Then, when you form a circle and a square, what kind of circle, what kind of square, what are the dimensions of the circle and square that you get? Well, you're going to get one is going to be the circumference of the circle, the other is going to be the perimeter of the square. Then you ask yourself, okay, now what's the area of that circle going to be, and what's the area of that square going to be? And then you write down their sum and see what kind of a function you have. Well, okay. We want to talk about areas. Before we answer the question, what's the area of the circle and what's the area of the square, let's be straight on how we're going to get those areas. How do you get the area of a circle? Well, it's pi times r squared. Of course, we don't know what r is, but that's progress. Pi times r squared. What's the general area of a square? Somebody put down length times length. Yeah, it's the length of a side times the length of a side. That's the area of your square. Okay, how do we get the area of a circle from the circumference? Well, that turns out to be a fairly complicated question. We have this question. We chose to answer this question first. Length of the side of a square. From the perimeter, knowing the perimeter, how do we get the length of the side of the square? Well, it took a while. It took a while for people to see this because, and I keep saying it, the geometry's been almost totally dumbed out of the curriculum, so nobody comes into a pre-calculus or calculus course knowing very much geometry, and it's a big handicap. And of course it's up to us to overcome it. Okay, so the side is related to the perimeter by the fact that you got 4 sides that add up to the perimeter. So the side is 1/4 of the perimeter. The perimeter is 36 minus x. So the side is 36 minus x over 4. Okay? Now, trouble getting to this. Okay, well, what do we want to do? The area is pi r squared. We know that. But how do we get r knowing the perimeter or the circumference? Well, that comes down to the fact that there's a formula you were taught to memorize without understanding what anything meant, most likely, not necessarily. Circumference is 2 pi r. Okay, that's a formula. Well, that circumference that is 2 pi r comes from the fact that pi is defined to be the ratio of the circumference of a circle to its diameter. So the diameter of a circle has to be circumference divided by pi. Or the circumference has to be pi times the diameter. The diameter is twice the radius, so you got circumference is 2 pi times the radius. So, one way or another, if you know this, then the radius is the circumference divided by 2 pi. Just solve that for r. And the circumference, back in terms of our variable, is x. So the circumference is x over 2 pi. So I'm sorry, r is x over 2 pi, okay? Circumference over 2 pi, x is circumference, x over 2 pi. So that our area is pi r squared, r is x over 2 pi, so the area is pi here times r squared, x over 2 pi quantity squared. Here's our formula for the area in terms of our variable x. Well, that's a fairly complex process. Probably unrealistically complex unless we understand very, very basic geometric facts, much less Euclidean geometry. And understand them, know how to use them, and so forth. Okay. Okay, we conclude that the total area of the circle plus the square is pi times x over 2 pi quantity squared, as we saw previously, plus a 36 minus x over 4 quantity squared. Pi times the radius squared plus the length of a side of the square squared. Okay? This is a quadratic function, isn't it? Okay, if you expand this, you're going to get x squared and x's and constant numbers. And don't let the fact that you got pi in there distract you too much. It's just another symbol for a number. We know what it is, so it's not variable. It's something we can deal with. A little messy, but we can deal with it. Okay, it's a quadratic function. Now, what's our goal here? Our goal is to find the minimum total area. So we want to find the minimum of this. Now, there are calculus techniques for doing that, but we don't know the calculus. We don't have those techniques available to us. But we know this is a quadratic function, so what do we know about its graph? It's a parabola. Okay? The vertex of the parabola has a y-coordinate that's either the maximum, if the parabola is shaped like this, opens downward, with the vertex at the top, or the minimum, if the parabola is opening upward with its vertex at the bottom. So the y-coordinate of the vertex is either the maximum or the minimum value of the function. So we have a quadratic function here, and all we have to do now is find the y-coordinate of its vertex, something that we hopefully mastered a couple of weeks ago. Well, to do that, we want to put this in the form ax squared plus bx plus c, because we know that the vertex lies on the axis of symmetry, which is at negative b over 2a. And we read that right out of the quadratic formula. Okay, we've got to do a little algebra to get from here down to here. Now check my algebra, check my symbols and everything, because I'm doing this off the top of my head. I didn't know what question was going to be asked. So that it's possible that there are errors. Pi times quantity x over 2 pi squared. Well, that's x squared over 4 pi squared. So it's pi times x squared over 4 pi squared. 36 minus x over 4 quantity squared. I first write as 36 minus x quantity squared over 4 squared. Then I'll square the 36 minus x. Pretty sure 36 squared is 1296, and I kind of double checked that in my head, and yeah, that's right. And 2 times 36 is 72, so it's fairly easy to square that if you can square 36. And of course you can use your calculator if you need to. Okay, the pi here divides one of the pi's here, leaving us x squared over 4 pi. And we have this expression. Okay, well, we want to get this into form ax squared plus bx plus c. So we have an x squared term, x squared over 16 comes out of this. We match it up here, so we got x squared over 4 pi plus the x squared over 16 that we got over here. Then we have minus 72x over 16 plus 1296 over 16. Here we factor out the x squared, so the coefficient of x squared is 1 over 4 pi plus 1/16, which we then put over common denominator 16 pi. We get 4 plus pi over 16 pi. 72/16 is 9 halves, so we've got a negative 9 halves here. Pretty sure 1296 over 16 is 81. Double check me on that. Actually, I'm not sure about that. 8 times 16 is 108, so it'd be 1080. Another 16 would not give us 1296. Okay, well, I figured that from 1600. This is 304 less than 1600. And 304 is 19 times 9 times 16. It should be 9 times 16, not 19. That should be 91. So all my 81s should become 91s. And I haven't used the 91 or the 81 again on this board, so when we get to the next one, I'll hopefully remember to correct that. Okay, so anyhow, there we have it. And now we can use our negative b over 2a to get the vertex. Okay? Negative b is being negative of negative 9 halves, and 2a would be this expression here, 4 plus pi over 16 pi, the coefficient of x squared, times 2. We simplify this, and we get, I hope, how did I get that? We have a 4 down there, and the 16 becomes 9 halves, and we've got 8 pi over 4 plus pi. Okay, I didn't do anything with the 2 except, yeah, 2, okay. 16 divided by the 2 gives us 8, that gives us our 8 pi, reciprocal of the denominator over 4 plus pi. Checking myself here, because the number I get here isn't necessarily all that close to what I would intuitively have thought. I would have thought that, never mind, I thought it backwards. Okay, so I thought something that wasn't true. Anyhow, we simplify this. 2 times 4 plus 2 pi is 8 plus 2 pi. Now I could have divided the 2 into the 8 and kept that a little simpler. And 9 times 8 is 72, so we got 72 pi. And of course I could reduce that to 36 pi over 4 plus pi. But 72 pi found convenient gives us something a little over 210. 8 plus 2 pi is a little over 14. 14 into 210 is 15. 10 times 14 is 140. 5 times 14 is half of that, 70. 40 and 70 is 210. Anyhow, I get something close to 15. Okay, well that's the axis of symmetry. To get the y-coordinate of the vertex, which is what we're ultimately after, I have to evaluate this function at the axis of symmetry. Got to be careful where I step. There are all kinds of obstacles here. So we have to plug in this result here for x. And we probably ought to plug it in symbolically instead of an approximation, but I'm not going to object if you take a calculator and get a good approximation of this number. So you can plug in here and get a good approximation of this number. So you multiply it by the square of that number. Okay? You do that and you end up with an estimate of your minimum area. Now let's see, 4 plus pi is around 7, that's around 48. This is about 1/7. X squared would be 225, 15 squared. 1/7 of that is around 30, a little over 30. And then you add 91, you're going to get 121. And then minus 4.5 times 15 is about 70. So what did I have? Lost track of my numbers already. Yeah, about 30, 121. Now I've lost track of this number. It's going to be around 70. So get maybe around 50. Okay? In any case, your minimum area is your function a of x. Okay, remember this is an a of x function evaluated at 72 pi over 8 plus 2 pi, which I probably should have written 36 pi over 4 plus pi. I'm not going to make that change. This parabola looks like this. Minimum y value occurs at the vertex. Oh, thought I'd done a little more, but apparently not. Okay.